Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is limits and derivative. This is an introductory video in this topic. So what is limits? It is a fundamental concept used to describe the behavior of a function as its input approaches a certain value. So for example, we have considered a function f of x. This is called f of x. For example, x square plus 3 is a function in x. So we have to write the limit as limit x tending towards a, f of x is equal to L. So in other words, the value of the function gets closer and closer to L as x gets closer and closer to a without being exactly equal to a. So you may be wondering, if f of a is existing, then why we need to find this limit of x of a, x tending towards a. Why we need to find limit? This is a very important concept which we'll be discussing in this video. Now consider a function f of x equal to x square minus 4 by x minus 2. Let us try to understand this function before finding the limit. So what happens at x equal to 2? Let us see. If you put x equal to 2 here, numerator becomes 2 square minus 4, which is 0. Denominator also will be 2 minus 2, which is equal to 0. So if we want to evaluate the function, this function at x equal to 2, the function is not defined. That's what we have written here. At x, this is x here, x values here, and this is f of x given here. So at x equal to 2, exactly at x equal to 2, f of x is undefined. So in such cases, often in such cases, when a function is not defined at a point, we would like to know what is the value around that function. So this is very important. That is why the concept of limit is coming. The limit value is not the function value at that point. This we should try to understand. In limits, we are approaching the value of the function at x equal to 2, while in the value of the function we put the exact value of that point for which we want to evaluate the function. It will be clear. Slowly we will understand this. So what happens? We want to get limit x tending towards 2 for this function. What we do, on the left side of the 2 or the lower values of 2, we'll put small values which are closer to 2. For example, say 1.9, 1.99, 1.999, 1.49, and we want to see what is happening to the f of x. So once we put 1.9 here in this equation, we'll get f of x 3.9. Similarly, when we put 1.999, we get this expression. We put x equal to this value and evaluate this value, this function, we get it as 3.999. Now let us see on the right hand side of 2. So it means greater than 2 values. So we'll put small values closer to 2, say 2.001, 2.001, and so on. And once we put these values into this f of x, we compute the value of f of x as 4.0001 for the corresponding x values. So it means if I put x equal to 2.1 in this equation, x square minus 4 and x minus 2 with x being 2.1, I will evaluate this full expression called as f of x as 4.1. So what we understand from here? We understand that if we go from the left hand side of 2 and approach towards 2, we get the value of function close to 4. Similarly, if we go from the right hand side of 2 and we approach 2, we get function close to 4. The value of the function being close to 4, but not at 2. At 2, the function is not defined. So let us try to summarize this what I have told. We have taken this function. We are trying to find limit x tending towards 2. We have evaluated at 1.9 to 2.1, closer to 2. And we see that limit x tending towards a minus we have written. A minus means coming from the left of A, is the expected value of A at x equal to A given the value of f near x to the left of A. So x tending towards A minus means we are coming from the left of A. So this value say 3.9999 is called the left hand limit of f at A. This is the left hand limit. When we are approaching a given point from the left hand side, the limit is left hand limit. Similarly, when we are approaching from the right hand side, we write limit of f of x where x tending towards A plus. It means we are approaching A from the positive or the right hand side of A. So this is called the right hand limit of f of x. Now it is important that the limit should exist if the right hand and left hand limit coincide. We call that the limit f of x at x equal to A denoted by this. So for this function x square minus 4 by x minus 2, the limit extending towards for this f of x exists and its value is equal to 4. We have seen here it is coming 4. On the left hand side it is coming closer to 4 and also right hand side it is coming closer to 4. So why we have to find the limits? We have seen that when the value of the function is not defined at a given point, it may be defined at other points, but suppose I want to define this function at x equal to, it is not defined, but we would like to know what is the value of that function closer to that point. So we use the concept of limit. It is important that left hand side of the limit and right hand side of the limit must be equal for limit to exist. This is very important. If left hand side limit is not equal to right hand side, then we say that the value of limit or the limit does not exist at that point. We'll see one case that also. Let us see this case. And before we move to that, it is important that the value of a function is not same as limit of a function. Let us try to understand in more details. At f of x equal to 2, value of a function is not defined. However, limit of a function is defined at x equal to 2. So we found that limit is 4. Let us try to plot this function. X square minus 4 by x minus 2 we are plotting. This is a straight line. We are getting a straight line. But what happens to x equal to 2? We have put a break there. We have put a circle there. It means at x equal to 2 the function is not defined. At all other point it is defined. So limit of a function is not the same as the value of function. This is very important. So you may be thinking that okay, whenever the function value is not defined, limit of a function we'll try to find and it will exist. The answer is to some extent yes, but sometimes no also. Sometimes value of function also may not be defined and limit of a function also may not be defined. Let us try to see that with an example. Now consider a function f of x equal to x plus 2 when x is less than 3 and f of x equal to 7 when x is greater than or equal to 3. We want to find what happens at x equal to 3. Let us try to find it out. So let us plot this for ease of understanding. So x less than 3, this is x coordinate, this is y, this is y equal to f of x. So we'll plot x plus 2 here less than 3. So it will be this blue curve. We can see here when x is less than 3. When x is greater than or equal to 3, it is 7. So at 3, exactly at 3, not for this case. That is why I put a circle here that is not being included. Dark circle means it is being included. So function remains constant. So 7. So x greater than 3. F of x or y will remain 7. That's what we have plotted here. We want to see what happens at 3. So for limit to exist at x equal to 3 or x tending towards 3, not x equal to 3, I am sorry, it is x tending towards 3, then left hand limit and right hand limit must be equal. This is very important. So we have to see, so we have to show if limit to exist, limit x tending towards 3 minus means coming towards left of 3 of x should be equal to limit of x tending towards 3 plus f of x, where f of x is given by these two. Now if we come from the left hand side, we use a rule called as, we write it as 3 minus h. So we, instead of writing like 2.99, 2.999, 2.49, we write in mathematical notation as 3 minus h, where h is tending towards 0. So any point on RHS or right side of 3 will be 3 plus h, where h is tending towards 0 or h is close to 0. Then only we will get it around 3. So let us try to write, how to write it. So left hand limit is x tending towards 3 minus f of x, limit h tending towards 0, f of 3 minus h. So f of 3 minus h. So what is f of 3 minus h? Because it is less than 3, wherever x is there, we will put 3 minus h. Other terms we will keep it as it is. So this will become 3 minus h plus 2. That's what we have written, 3 minus h plus 2. H tending towards 0. So this will be equal to 5. H is going towards 0. So 3 plus 2 is 5. Let us take right hand limit. So we write it a limit f of x tending towards 3 plus. We are coming from the positive side. So the function is f of 3 plus h. So wherever x term is there, we will write 3 plus h. But in this only constant term 7 is there. So answer will be 7. Because no x term is there. So the function is constant 7. So what we see, that the left hand limit is 5, right hand limit is 7. The value of the two function is, or from the left hand limit and right hand limit is not equal. 5 is not equal to 7. Therefore limit does not exist. So this is very important. Limit for this function at x tending towards 3 does not exist. Now let us try to use some few algebra on limits or the theorem on limits, that if two functions f of x and g of x are given and the limits are put as x tending towards x0, then the limit of their addition is equal to addition of their limits. Similarly, it holds for subtraction also. Similarly, for product also, limit of the product of two functions is equal to product of the limit of the two functions. Similarly, if k is a constant or some scalar, then and it is multiplied by a function and we are taking a limit, then k can be taken out. K can be taken out and limit can be taken for the function. Similarly, limit for two divisible function f of x by g of x is the division of the limits of the functions, with the condition that the denominator must not be equal to 0. Now let us try to find the limits of some rational functions. So what is rational function is, which is in the form p by q, some divide by. So this is a rational function, it is in p by q form, it has a numerator and a denominator. We want to find x tending towards 1. Let us try to find out this. So x tending towards 1 means first we will put 1 in this, x equal to 1 in this expression, and then see what happens. If it is coming like 0 by 0 form or 1 by 0 form, then it means the limit has to be computed. Let us put x equal to 1 here. So x equal to 1, 1 square plus 1 divided by 1 plus 100 will be 2 by 101. So directly we get the answer, which is not coming in any 0 by 0 or 1 by 0 form. So we get the answer directly as 2 by 101. Now let us take another example where the expression becomes in 0 by 0 form. Let us take like this. What is 0 by 0 form? So we'll understand. This is a function. This is a rational function. In this we want to take limit x tending towards 2. Let us put 2 in this x expression here in the numerator and denominator. 2 cube minus 4 into 2 square plus 4 into 2 divided by 2 square minus 4. So numerator will become 0, denominator will be 0. So just by substituting 2, we are not able to get the answer as in previous example. So how do we proceed now? What shall we do? We will try to expand this or find the factors of this and try to cancel numerator and denominator some factors if it is getting cancelled. So Let us put x square minus 4 as x plus 2 into x minus 2. Similarly, we can take x common. If you take x common, and it will get a quadratic equation. If you find the factor, it will be x minus 2 the whole square. So x minus 2 and x minus 2 will get cancelled. Numerator will be x into x minus 2. Denominator will be x plus 2. So x is tending towards 2. If you put x equal to 2, 2 into 2 minus 2, which is 0 by 4, which is the 0. So the limit extending to 2 for this expression is 0. Answer is 0. Now this is very important theorem for solving some examples in your NCERT book. You must try to remember this formula for any positive integer n. Limit extending towards a for a function x power n minus a power n by x minus a is equal to na power n minus 1. So let us take one simple example. Limit extending towards 1 x power 15 minus 1 by x power 10 minus 1. How do we solve? If we have to convert this into this form, we see that x power 15 minus 1 is there. If we can divide by x minus 1, then this can be put in this form. So we divide both numerator and denominator by x minus 1. We have divided this expression by x minus 1. So it is in this form. Now the solution for numerator will be na n minus 1. Here n is 50, 15a is 1, n minus 1 is 14. So 15 into 1 power 14. Similarly here it will be 10 into 1 power 9. This is 1. So 15 by 10 is 3 by 2. This is the answer. Now we come to trigonometric functions. Does limit exist for trigonometric functions? Yes. Answer is yes. So we'll just give the final answers as we are not going for any derivations for you. So limit extending towards 0, sine of x is 0. We know that sine x is 0 when x is 0. Similarly, limit extending towards 0, cos x is 1. Tan x again it is 0. This expression is very important. These two expressions are the fundamental theorems which you must remember. That limit t tending towards 0. We can put x as t also. No? Any variable name we can put. So we have put t here. If you are not convenient, you can put x also. So there is a limit t tending towards 0, sine t by t is equal to 1. Similarly, limit t tending towards 0, 1 minus cos t by t is equal to 0. This is very important. Now we'll come to derivative of a function. Derivatives are an important concept in class 11 which you'll be using not only in your 12th class but in throughout your career or in higher studies you'll be using the concept of derivatives. So pay attention here students. So what is f dash x? We know f of x. F of x is a function of in x. When you put this dash symbol here, it is called the derivative. So f dash x means this is derivative of a function f of x. How it is defined? It is defined as this: limit delta x tending towards 0, f of x plus delta x minus f of x by delta x. What is delta x? This symbol is called delta. Delta x means a small value of x. For example, if x equal to 2, then delta x is 0.0001. So it is a small value which is near to x. So x plus delta x will be a small point near to x. So what happens? What we are doing here? We are finding the function value which is close to x, subtracting it with the function value at x divided by that difference. So a derivative is something like a rate of change. So that we'll see in the next figure how the concept is. And the derivative of f of x at x equal to a. We want this answer specific at x equal to a is given by this expression. F dash a, limit h tending towards 0, f of a plus h minus f of a by h. We'll try to understand with a figure what is derivative. So we have put this. We are trying to find the derivative at x equal to a given by this expression. So what it means, what is this? We'll try to understand this. In this figure, this is the function. This red color, you can see this curve. This is a function f of x, any f of x at different x, we are plotting the value of y or f of x. Y is f of x. So like if x equal to 2, y will be this value. If x equal to 3, y will be this. So we are plotting this function. So this red color is that function. Now we want to find the derivative at this point. What is this point? Let us draw with the dotted line here. Let this be a point A at x equal to a. This is x at x equal to a. We want to find the derivative at this point at x equal to a for this function f of x or this function. This is some arbitrary function I have drawn. Now question comes, how do we do it? We will find a point close to this point. Although I am showing a point little away, actually it is close. This is h, means this distance, this distance is h. So this point is a. Actually we want to find the derivative. We select another point which is close to a and its difference is h. So we are finding f, this point is a plus h. So we are computing the function value at f a plus h. This is h is the difference. So this is a, this is h. So this point will be a plus h coordinate. So we are finding the function value at that point. We are finding the function value at this point. So we are finding at 2 points. This I have put cross here. So we are finding the value of function at f of a. We are finding the value of f of a plus h. The difference divided by this small distance h is giving the derivative. So what physically it means? Let us try to understand what physically it is meaning. At point P, if we draw a tangent line will touch a function or a curve only at one point. So it is touching only at P. So the slope of this line, what is slope of this line is tan theta, we know that. So the slope of this line is the gradient or the derivative of the function. So few terminologies here used: tangent, derivative, gradient. So this can be used interchangeably. You can use any word. So presently we use the derivative. So derivative at point P is the slope of the curve, slope of this curve. So slope of this curve is given by this tangent and it is given by this formula. I hope it makes some sense to you. Now let us see some few theorem on derivatives. Here we have two functions f of x and g of x. So d by dx of the two functions, we can give d by dx into f of x plus d by dx into g of x. So derivative of two functions is the addition of the derivative of two functions. What is d by dx? Like we have seen previously, we have used the word delta x. Delta x means it is very close to x. This does not mean delta into x. Please note, delta x is not product of delta and x, but it is a notation. It tells small change in x. Similarly, this is equal to dx. What is dx? We have in the denominator we are writing dx. Dx is same as delta x. It is not d into x. Dx is small change in x. So that's what we are writing. This is a way of writing derivatives. So d of dx f of x is same as f dash x, we have seen earlier. So f dash x and d by dx f of x meaning same. It means this is derivative of f of x, this is derivative of g of x. This is same as this. For a derivative of g of x, we can write g dash x. That's all. Similarly, for addition, difference, derivative remains like this. But two important formulas are there. when we take product of the two functions and we want to find the derivative, it is this formula we have used. Let the first function be f of x, second function be g of x. We want to find derivative of that. Then the formula is, remember like this, first function into derivative of second function. This derivative of second function. First function into derivative of second function plus second function into derivative of first function. This formula is important. You will be frequently using. Similarly, for division, we want to find derivative of f of x by g of x. How do we do it? We use this formula. How to remember this? First, you put this line and put denominator term as square of this. So how we should remember? Denominator the whole square. Denominator the whole square. Then in the numerator, how will start with denominator? Denominator into derivative of numerator minus numerator into derivative of denominator. So this is the way to remember. For derivative of f of x by g of x, denominator the whole square. In the numerator we write denominator into derivative of numerator minus numerator into derivative of denominator. You have to remember this like this. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.